The universe feels governed by rules, stable, predictable, unbreakable. You are taught that physics is the study of these rules, that once discovered, they apply everywhere and always. Laws feel like constraints reality cannot escape, but physics itself tells a far stranger story. The universe does not merely obey rules. In critical moments, it appears to break them, not by accident, not through error, but as a fundamental feature of how reality operates. And physics knows this, even if it rarely says it plainly. The discomfort begins when you realize that many of the most important events in the universe only occur because rules fail, exceptions appear, or symmetries are broken. If the universe obeyed its rules perfectly at all times, nothing interesting would exist. No structure, no complexity, no history. Order would remain frozen. Change requires rule breaking. This is not metaphorical. It is written into the equations. Consider symmetry. In physics, symmetries define laws. They encode conservation principles. When a symmetry holds, something is preserved. Energy, momentum, charge. These are not optional features. They arise from symmetry itself. And yet, the universe is full of broken symmetries. The early universe was highly symmetric. Forces were unified. Particles were indistinguishable. As the universe cooled, those symmetries broke. Forces separated. Particles acquired mass. Structure emerged. The universe did not violate its laws when this happened, but it did violate its own symmetries. And those violations are the reason anything exists. If symmetry had remained perfect, there would be no atoms, no chemistry, no stars. Symmetry breaking is not a bug. It is the engine of reality. This pattern appears again in quantum mechanics. Quantum rules allow superpositions, interference, and reversibility. But the classical world you experience does not behave that way. Something breaks the symmetry between possible outcomes and actual outcomes. Measurement selects one result. Decoherence suppresses alternatives. The rules allow multiple futures, but reality chooses one. This selection is not dictated by the equations alone. It emerges from interaction, environment, and amplification. The transition from possibility to fact is not fully governed by the fundamental equations. It is a controlled breakdown. The universe follows rules that contain their own failure modes. Nowhere is this more unsettling than in causality. Physics teaches that causes precede effects, but under extreme conditions, this rule bends. Quantum entanglement produces correlations that defy classical causal explanation. Relativity allows space-time geometries where causal order becomes ambiguous. In some solutions, time loops exist. The universe permits structures where the notion of before and after loses meaning. These are not mistakes. They are allowed by the rules themselves. Physics does not patch them out. It accepts them and tries to understand their consequences. This reveals a deeper truth. The laws of physics are not absolute prohibitions. They are constraints that allow exceptions under specific conditions. They define what usually happens, not what must always happen. This becomes even clearer when you consider conservation laws. Energy conservation feels sacred, and yet, in quantum mechanics, energy can fluctuate temporarily. Virtual particles appear and disappear. Energy is not conserved at every instant, only statistically over time. The universe bends its own accounting rules as long as the averages work out. Even space-time itself is not immune. In general relativity, global energy conservation is not well defined in an expanding universe. Energy can appear to be lost or gained depending on how space-time evolves. The universe does not violate its rules. It exposes their limits. The rules apply within frameworks. Change the framework and the rules change. This is deeply unsettling because it undermines the idea of laws as eternal constraints. Instead, laws become contextual. They hold where their assumptions hold. Break the assumptions, and the laws dissolve. This is not failure, it is structure revealing itself. Consider vacuum decay. Physics predicts that the universe may exist in a metastable state, a false vacuum, stable for now but not absolutely stable. A lower energy state may exist. If a transition occurred, the laws of physics as you know them would change instantly within an expanding bubble. Particles would have different masses, forces would have different strengths, chemistry might not exist, space-time itself could behave differently. This would not be a violation of the laws. It would be the universe following deeper rules that allow phase transitions. The laws you experience are not guaranteed, they are maintained. This realization reframes certainty. Physics does not promise permanence, it promises consistency within a phase. The universe can and does break its own patterns when conditions change. Another example lies in singularities. According to general relativity, singularities are places where the equations break down. Density becomes infinite. curvature diverges. The laws stop making predictions. This is not because the universe becomes lawless, it is because the laws we have cease to apply. Singularities mark the boundary where our rules no longer work, and the universe produces them naturally. Black holes are not rare anomalies, they are common. The universe creates regions where its own description fails. Physics does not hide this, it acknowledges it. This is one of the strongest signals that our laws are not final. A final theory would not break under the conditions it predicts. The fact that current laws do tells us something essential. The universe is deeper than its current description. The rules are approximations, extremely good ones, but approximations nonetheless. Even randomness plays a role. Quantum mechanics introduces fundamental unpredictability. Not ignorance, not lack of information, genuine indeterminacy. The universe does not fully determine outcomes even when the rules are known. This is not a violation of law, it is a feature of law. The rules allow randomness. They include uncertainty as a structural element. This means the universe does not fully control itself. It leaves room for outcomes not fixed in advance. And that room matters. It allows novelty. It allows divergence. It allows history. If everything were rigidly determined, the universe would be static in a deeper sense. The combination of symmetry breaking, indeterminacy, and phase transitions means the universe is not governed by rules in the way a machine is governed by instructions. It is governed by frameworks that permit their own evolution. The universe breaks its own rules because the rules are not the deepest layer. They are emergent regularities arising from deeper constraints. When those constraints shift, the rules change. Physics knows this. It is built into the structure of modern theory. The discomfort comes from the way we talk about laws. We speak of them as if they are inviolable, but physics treats them as effective descriptions. They are stable patterns, not eternal commands. This difference matters. It means reality is not locked into a single way of behaving. It has room to change, to transition, to reorganize, and those reorganizations are not external disruptions. They are part of the universe's own dynamics. The deepest lesson is this: the universe does not break its rules by disobeying them. It breaks them by revealing that they were never fundamental to begin with. What you call rules are the surface behavior of a deeper structure, and that structure allows, and sometimes requires, the breakdown of its own patterns. This is not chaos, it is coherence at a deeper level. The universe is not lawless, it is layered, and when one layer fails, another takes over. Physics knows this because it keeps encountering the same message. Every law has a domain, every domain has an edge, and at that edge, the universe behaves differently. Not incorrectly, differently. Understanding this changes how you see certainty. The laws you rely on are not promises. They are habits of a universe that has settled into a particular phase. Habits can persist for immense spans of time, but they are not guaranteed forever. The universe has broken its own rules before. It may do so again. And if it does, it will not feel like a violation. It will feel like a different reality with different regularities. Physics does not hide this possibility. It builds it into the theory. The rules you trust are real, they work, but they are not ultimate. And knowing that matters, because it tells you that reality is not a closed book. It is a system that can rewrite itself when deeper conditions demand it. This is Veritas Labs, where truth is tested.